Miguel is from Brazil. He did his bachelor degree in the University of Sao Paulo, Brazil, and now he's doing his PhD in Grenoble. And he will talk about cloud computing.
My name is Miguel. I'm from my first year in the Ph.D. at the University of Grenoble. And today I'm going to talk about a little about the problem that I'm studying in my thesis. That is, how can we optimize the green energy utilization on cloud computing platforms? So let's start. Firstly, cloud computing made a revolution in information technology with its ability to provide large amounts of computing resources on demand. Let me give an example. Suppose that you have an idea for a social network to engage people in to fight the climate change. And initially you use your laptop to host this social network. But suddenly your social network is becoming very famous. Millions of users want to access it. Your laptop will not be able to process all this information. So you need more computing power. So what you do? So before cloud computing, you would have to buy more computers, and you waste not only money, but also time, because you would also have to configure all these new computers. But now with cloud computing, you can access these resources on demand, and you pay only for what you use. And nowadays, most of the services and applications we use are already supported by cloud computing platforms. And in the future, smart cities and the future internet will also rely heavily on these platforms. So here I have an image of what these clouds really look like. We can see that they are building thousands of computers that we call servers. And these buildings are called data centers and are distributed all over the world. And what's the problem? The problem is that these data centers consume a massive amount of energy. You can see that this is the most recent data that I have. They consumed 200 terawatt hours in 2019. And this is about 1% of the global power. Just to compare, here we have how much each country generated in the same year. You can see that a lot of countries in the world are generating less energy to supply their needs than what the data centers are consuming. And the problem is also because most of this energy comes from non-renewable sources, so causing a huge impact in the environment. So one possible solution to reduce the environmental impact is then to try to integrate more renewable energy. And in fact, many of the major companies like Apple, Facebook, Google, Amazon already made commitments to be 100% green. And some of them are already deploying solar panels in their data centers. But however, using the renewable energy is not so easy. There's a major challenge caused by the intermittency. That means that the green energy is not available all the time. So here I have this example to help me explain a little about intermittency. So this is from a screenshot from a service that is called Electricity Map. You can see in real time how green is the energy that is being produced all over the world. And you can also get some information like the solar power that can be produced in real time. So for the time of the day. At night, you know that there's no solar production at night. And even during the day, the solar light intensity is not constant. So for example, here I took this at almost 19 o'clock in Paris time. And you can see that most of the solar intensity was over the Atlantic. So not very good for the generation. Also the climate, here you can see that like these clouds creates a barrier to the sunlight. The seasons, the different seasons, we have a different amount of daylight, and also the geographical location of the data center. Because here, as you can see, the green energy availability is very different all over the world. And how do we are planning to address the intermittency in my work? So we are planning to use the scheduling. Scheduling is basically defining when and where the tasks will run. So for example, for your idea of the social network, if you notice that most of your users are from Europe, maybe you could select a data center in this region to reduce the delay for them. And one interesting characteristic is that the workload can also be transferred. We call this migration between servers from the same or from different data centers. So if you notice that at some moment, most of the users are coming from the United States, you could migrate your task to run here to reduce the delay for your users. And among scheduling, we are planning to use two main approaches. The first is called server consolidation. The aim of this is to minimize the number of servers that are on. And why? Is because the servers consumes almost half of the total electricity of the data center. And here we have an example. So here we have 3 servers in our data center. We can see that they are not completely used. So we can migrate the task among the servers to minimize the servers that are used. So now using one server, and we can shut down these 2 other servers and then save a lot of energy. And the second approach is called geographic load balancing. Basically, we aim to migrate our tasks to the data centers that have more availability of green energy. So, but for using these 2 approaches, we need to take into account some factors. The first would be the network's cost, because when you migrate, you are using the network. So if you migrate a lot of tasks at the same time, they will compete for the network, and the migration will take a lot longer. It's like when many people try to use your Wi-Fi at home, so the speed will decay. And also because these migrations consume energy, not only for the servers, but also in the network equipment. So if your migrations are taking longer, they are also consuming more energy. And finally, these clouds need to provide some quality in the service in terms of availability, reliability, and also performance. So if we migrate a task from Asia to the North America, maybe the delay will not be so good. So you could probably choose a region that is closer to reduce the delay. And the second approach is we studying to use energy storage device. These devices are already used in data centers as backup for when a power outage occurs. And recent studies are trying to store the green energy in this device to use when there is no production of the green energy. For example, you store during the day and you use it during the night. And among all the energy storage device, we are considering to use the batteries because they have the best cost benefits in terms of cost, like the cost to store the energy, also the power is the rate that you can use the energy, how fast can you use the energy from this device, also the density, how much space they will need, because the space is a very important resource for a data center. You could use this space to add more servers or also to improve cooling. And finally, the self-discharge, because even if you're not using the energy from the batteries decays, and the batteries have the best self-discharge rate among all the energy storage devices. So the question is, how do we define the ideal dimensions of batteries and solar panels to meet the demand of a data center? Because it's not simple as use as much as you can, because this device also presents a carbon footprint. For example, for solar panels, if by 2050, 40% of the global electricity is produced by the current state of the art solar panels, they would consume about 5% of the today CO2. And for the batteries, the main carbon footprint comes from the manufacturing. And they have a characteristic that's called maximum depth of discharge. That is basically, if you do not use the battery completely, if you do not discharge it completely, it can live longer. But this causes that you will not be able to use all the capacity of the battery. So they are usually oversized. And because of this, they also have a bigger carbon footprint. And finally, the recycling rates also needs to improve. So here is this overview of my project. So the objective will be to use these questions to try these approaches of scheduling and also energy storage device to try to optimize the green energy usage in cloud computing platforms. How will will develop it. You use computational simulations just because of costs and time. Is if you use real clouds, we spend a lot of money. It also consumes a lot of energy. And when using simulations, we need to be careful with the value of the results. So we use tools validated by the scientific communities to increase the confidence in the results. And also the input will be with real world data from the workload, the solar energy traces, and from the attributes of the batteries. And how to evaluate, we can compare with other state-of-the-art for the schedulers. That is the program that will define when and where your task needs to run. And some metrics that we can use: the total electricity consumption, the green energy usage, and also the time to find a schedule, because deciding is not an easy process. And if you took a very long time, like where can I run my task in all those data centers and servers, it will decay the quality of your servicing. And finally, the outcome will be this algorithm that we are developing that could be incorporated by these cloud computing platforms, and also this intelligence of how much solar panels and batteries you need to meet the size and the demand of a data center. That's it. Thank you very much.
Well, Miguel, that was a very nice presentation. We learned a lot. And now we will jump to the question. So so the first question, it's about it's by Laurent. So Laurent asks you, the question is, what is your point of view about parallel topic? Producing mining cryptocurrencies requires enormous electricity resources. According to expert in digital, it is the next ecological disaster. So what's your opinion about that?
Because in fact, it consumes a lot of electricity, and is nowadays also causing like this for mining cryptocurrencies. They use like graphic cards, and nowadays it's very hard to find a graphic card because they are all being purchased by the miners. So in fact, they consume a lot of energy, but they seems to be the future. So we need to try to see how to improve using some techniques to reduce the energy consumption of these cryptocurrencies. Like I think that Ethereum is trying to reduce its carbon footprint, if I'm not wrong.
Okay. Well, we now have another question by Emily. So what social political factors could hinder or favor geographic load balancing? So I'm thinking, for example, about countries who might not want to share their data centers with others for safety spying issues, for example. And on the contrary, countries who share similar values and would therefore be more willing to take part into data management alliances. If you want more detail, go to Slack and you can read again the questions.
Here is the slide of geographic load balancing. Yes, this is a factor that can be included in the decision to avoid your task to executing specific data centers, but it also increases the complexity of the problem to deciding when and where you execute the tasks.
Audrey, so what about the environmental cost of batteries? We know that sourcing the materials to produce them is a major issue today.
You take into account this to define the ideal dimensions, not only we take into account the environmental costs, like for example, the manufacturing is the biggest contributor for the carbon footprint of the batteries. And they tend to be oversized because you, for example, you do not discharge the battery completely. You discharge it, it's like you need to remain about 20% of charge. So because of this, you need to make it bigger to be able to use more energy. So you ends up causing a higher carbon footprint because the batteries becomes bigger. So yes, I will take into account the carbon footprint to this decision of how much do you need to, it's basically how much batteries and solar panels do you need to build to supply the data center.
Well, in the meantime, I have a question for you. Because I'm a huge fan of cloud computing. I use it myself on a daily basis. So I'm very interested by your topic. And on your conclusion, you mentioned that here you say what is the outcome. So you want to build an algorithm that could manage all of this, resources management. And so who is going to build this algorithm? Is it going to be each cloud provider like AWS, Microsoft, Baidu, or Google that will build their own algorithm and try to optimize their energy sharing or energy allocation, or it's gonna be part of your PhD to design such algorithm? And in this case, you will need their data.
Basically, my PhD will be to develop this algorithm that could be integrated by them. But regarding the data, basically what I need is like how much computational resources do you need? For input could be like I need like my task will execute like we need 3 gigabytes of RAM and 2 CPU cores, and we will run for I don't know 1 hour. So you can use this information to decide when and where. So the algorithm they could incorporate this algorithm in their platforms. So I do not need to be aware of their sensitive data.
So basically, you will give your algorithm, you will open source your algorithm for them.
Yeah, the algorithm can be used by anyone.
Okay, and because this is very interesting, and do you have any idea about what type of algorithm you want to use? You want to build like neural network? You want to build like traditional machine learning, or it's going to be like hard-coded algorithm? Because I really like those kind of questions. So that's what I'm a bit interesting, because the complexity of your data makes that you need to use like state-of-the-art algorithm to tackle all of these very difficult questions, to allocate, to optimize, to those kind of energy resources. And cloud providers, they are state-of-the-art in terms of AI or this kind of stuff. So and what could be your your advantages compared to their in-house algorithm provided by AWS, Google, Baidu, Microsoft, and so on.
A scheduling algorithm. So, because the scheduling is not a easy task. For example, here to minimize the number of just minimize the number of the servers. It's basically a combinatorial problem. You would need to try all of the possibilities. It's like when for instance, you need to try to guess a password. You need to try all the combinations. So you need to have a huge number of possibilities. So there are special types of algorithms. There's called scheduling algorithms that they tries to find a possible good solution. It may not be the best one, but it's a good solution in a short time. You are trying to explore these algorithms. And you asked also about machine learning. You are trying to, you explore if it's possible to use machine learning in order to, for our model of renewable energies availability, to see, in this time you have energy availability, this time not. So we use this information to also include in the decision of the scheduling algorithm. and comparing with the current state of the art of what they use. And we don't know exactly what they use because they are not so open about the exactly algorithm. But as some of the, we plan to use computational simulations with tools validated by the scientific community to be closer to what is real, because some studies use models that are too abstract. So if we include the reality of the simulations, so you'll be closer to the reality, and they can be more confident in integrating these algorithms.
Thank you very much for your presentation, and thank you for your great answers. But I can chat with you more about this, this kind of solution that you will provide, because it's very interesting, this kind of topics.